Hello guys, so in this video we are going to discuss the solution of a problem, shortest common subsequence. So let us look at the problem statement. So in the problem statement says that we are given two string x and y of length m and n respectively. Find the length of a smallest string which has both x and y as its. So our objective is to find the smallest string which has both x and y as its subsequent. So let us take a look on it. So here let us say the string is basically, let us say there is a string x which contains a, b, c, d, and there is a string which contains x, y, c, d. So a super common subsequence for this string would be a, b, x, y, a, b, x, y, c, and d, right? So if you look into this string, this contains x as well as this contains y, right? A, b, c, d is there, a, b, c, d is there, whereas x, y, c, d is also present, right? So s is the super sequence of x and y, and we need to return length of s. Okay, so right, and we need to find the super sequence which is minimum. So it might be possible that there exist more than one super sequences, and if there exist more than one super sequences, in reality there will be more than one super sequences, but the question says that we need to find the minimum length super sequence. So that's about the problem statement. Now let us look at the solution of this. So let us first discuss the brute force solution for this. Brute force solution. So in the brute force solution, what we are going to do is basically, so m and n are the length of x and y, right? So we know that length of x is given by m and length of y is given by n. Okay, so what we are going to do is basically and let us say that m is less than n. Okay, let us just assume it, and in case, so basically what we are going to do is that find the minimum between m and n, right? So once we find the minimum between m and n, and let us say m is less than n, what we are going to do is generate all strings. So here basically permutation, so we are generating all possible permutation. Generate all string of length m. So we are generating all the strings which are possible with length m, and what are the characters it composed of? So the characters will be basically we'll take all the characters which are there in x. Okay, so all the characters which are there in x, we'll take it and we will generate all strings. So, and once we have generated all these strings, for each string check if y is a subsequence. Okay, subsequence of, and let us say for each string, so let us say I'm calling it as s, subsequence of s. If yes, then return m, right? We need to return size of the string. Okay, otherwise let us say after step 1 and 2 we are not able to find, so we are not able to satisfy a second condition. Let us say this condition is not satisfied. So in such cases what we are going to do is we are going to increment m by 1. Okay, and we are going to generate all the permutation of strings of size m plus 1, and the character should be composed of x as well as y. Okay, so the characters will belong from x and y, and similarly we'll keep on doing it. So for size m we generated all these strings, and we check if for that particular string. Now since it is being generated, so for that particular string, if x and y are subsequence of it, if so here I'm sorry, when we are talking about check if y is a subsequence, here we will check if y and x is a subsequence. Okay, so we'll generate all these strings, we'll check if y and x is a subsequence. If yes, then return m. Otherwise we'll go ahead and increase our length of super subsequence by 1, and we'll generate all the possible combination again, and we will keep on doing it till we find the super subsequence. Once we find the super subsequence, we will return m. We'll return m from there. Okay, so that's about the brute force solution. Now let us discuss the optimal solution for this. So the optimal solution is pretty straightforward, and it relies on, so let me just have it here. So we are discussing optimal solution now, and it relies on basically LCS. So what I meant is, basically, let us say length x and y are two strings which are given to us of size m and n. Okay, what we are going to do is that we are going to find the LCS of x and y. LCS is longest common subsequence. So we will find the LCS of x and y, okay, which is of length m and n. Okay, we are going to find LCS of this, and then the length of super subsequence is basically will be given by the formula m plus n minus LCS. Okay, so if you want to correlate it with it, if you want to correlate this, you can correlate it with set theory, right? So basically what I meant to say is, like, this is our Venn diagram. In this shape of Venn diagram, this is my x and this is my y, and this is something which is x intersection y. So x intersection y is nothing but the LCS. Okay, and the thing is, we wanted to find union cardinal number union of x union y, so which is given by the formula cardinal number of x plus cardinal number of y minus cardinal number of x intersection y. Okay, so this is what we are going to do, and we will be able to get the length of super common subsequence. So in this video, I'm not going to dwell on LCS. For LCS, I'll make a separate video and we can discuss more thoroughly there. But for now, let us move on to the coding part, and let us take a look on the solution. So I've already coded it. So what we are going to do is, basically, we are going to find the LCS, and this function, this is a function which I wrote over here, and this is going to give me the longest common subsequence, the length of longest common subsequence, and that I'm storing in a variable LCS, and towards the end I just need to return m plus n minus LCS. Okay, so that's the solution. Now let us submit the solution. Okay, so our solution got accepted. So that's about the video, folks. If you have any comments or query regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.